Hello from Switzerland. The early morning. I have a presentation about the tests, high voltage tests, especially with the partial discharge. You have here the lot of testing of GIS now. Already, I want to go in detail now with the high voltage test with the partial discharge measurement. So that's my presentation. I hope you can see it. In the IAC Standard is a list of all the tests to be done after installation on site. After installation and before being put into service, the GIS shall be tested in order to check the correct operation and dielectric integrity of the equipment. The list here comprises the dielectric test on the main circuit, the dielectric test on auxiliary circuits, measurement of the resistance of the main circuit, gas tightness test, several checks and verifications, and the gas quality verification. In the list here, the dielectric test on the main circuit should be at the end, time-wise at the end of all of the tests. For the dielectric tests, there are two procedures mentioned in the IAC Standard. There's a procedure A recommended for GIS up to 170 kilovolt and below. That's only a power frequency test during 1 minute. And the procedure B, additional to the high voltage test here, is also a partial discharge measurement according to table 6 in this IAC Standard. However, the dielectric test on the main circuit, it is mentioned, since it is especially important for GIS, the dielectric integrity shall be checked in order to eliminate fortuitous causes, wrong fastening, damages during handling, transportation, storage, and installation, presence of foreign bodies, etc., which may in future give rise to an internal fault. That's the reason to perform a high voltage test, a dielectric test. In order to check the integrity of a GIS after the site installation, the application of the procedure applied to the GIS of a rated voltage of 170 kilovolt and below, the procedure A. The high voltage test is a snapshot at the time of the test. Therefore, it's important to detect also hidden imperfections, like loose metallic particles, damages during handling, etc., which do not lead to a flashover during the 1 minute site test, but may become to an issue in service. Such imperfections may be detected by a partial discharge measurement during the site test. Such a test shows only a complete breakdown, not only a complete breakdown, but also a partial damaged insulation, which may rise to internal fault. In order to perform a partial discharge test, additional to the voltage source, a test transformer, for example, a coupling capacitor has to be installed, where the PD measurement system can be connected. On the secondary side, several PD measuring systems are available on the market. Important is not only the measurement of the PD level, but also the phase-resolved PD patterns in order to make an assessment of the PD source. Once the unacceptable PD is measured, the PD source has to be localized within the dielectric the test section. Loose moving particles might be localized by means of an ultrasonic detector. The test equipment should be connected directly to the GIS without SF6 air pushing to avoid secondary influences from the atmosphere. Here an example of such an installation. In red color, you can see the test transformer. This is a conventional test transformer in this case. On top here, the coupling capacitor, all connected to the GIS. This is a 3-phase encapsulated switchgear. Therefore, we have here a three-phase tapping switch to connect one phase, one by one of the phases, while the other two phases are internally grounded. In the IAC standard is also mentioned the test voltages to be applied during 1 minute. The test frequencies, the frequency of the test voltage should be between 10 and 300 Hertz. This is because not only conventional tests will be applied in the range of the 50 Hertz or 60 Hertz, but also resonant test kits where the frequency depends on the load can be up to 300 Hertz. Here the rated voltages of the GIS, and following here the test voltages. For example, a GIS of a rated voltage 145 kilovolt has to be tested at 235 kilovolts. Partial discharge measurement. There is a list here also in the IAC standard for system with solid earthed neutral and a list with system without solid earthed neutral. PD has to be measured on a GIS without solid earthed system neutral at 1.2 times UR. In case of a three-phase enclosed design, in case of a single-phase enclosed design, also at 1.2 times UR. In case of a system with solidly earthed neutral, there's a difference between three-phase enclosed design and single-phase enclosed. The single-phase enclosed switchgear has to be tested also at 1.2 times UR. Divided by √3, while the three-phase enclosed design has to be tested also at 1.2 times UR. So this is the difference between three-phase enclosed design and single-phase enclosed switchgear during the high voltage, during the PD measurement. If procedure B is used, and if the partial discharge are measured without the conventional method according IAC 60-70, the maximum permissible intensity of partial discharge shall be 10 picocoulomb. This is for the site test. There is also mentioned that it can be difficult to have a noise level below 5 pico on site. Specially care with the test circuit is needed to achieve a good measurement. If the noise level is higher than 5 pico, the test is still valid for detecting major defects, but not suitable for detection of fixed conducting particles, since this kind of defects will cause a very low level of partial discharge, and they will be completely masked by the noise. In such circumstances, the test is acceptable if no discharges are detected above the noise level. Here the test circuit for the high voltage test and partial discharge measurement. On the left side, you can see the test transformer. Inside the capacitive voltage divider, via this voltage divider here, the voltage can be measured. Connected to the terminal of the test transformer, the test object, and via an internal disconnector in parallel, a coupling capacitor, where on the secondary side a partial discharge measurement meter can be connected. Also on the test circuit is a earthing switch, which is isolated earthing switch, which is shorted on the secondary side during test and can be used before the test for the calibration of the circuit. Here, the principal circuit with the capacity of the GIS, and here the coupling capacity. In case of a partial discharge, just a part of the GIS of the capacitor is shorted here, and this creates a current in this loop. This current has to be supplied by the coupling capacitor. In order to measure the PD now, this coupling capacitor is connected to a quadrupole here, and this current in this loop creates a voltage drop at the end of this quadrupole. On this quadrupole, PD measurement instrument can be connected, and this PD measurement instrument is showing the discharge in picocoulomb. This is the 1 picocoulomb is 10 exponent minus 12 coulomb, while the coulomb is the amperes multiplied by the seconds. Different parcel discharge measurement instruments are on the market. This one is an instrument from Power Diagnostics, which is showing also the patterns, the parcel discharge patterns, which are important to make an assessment of the source of the parcel discharge. This, for example, are typical patterns of loose metal particle. You can see here the voltage, the positive, negative amplitude. At the point where the voltage is 0, there are practically no discharges, and the maximum discharge, the maximum of the patterns are always at the maximum of the voltage, positive and negative. A high voltage test, including a conventional parcel discharge measurement, is just a snapshot at the time of the test. The test equipment will be removed after the test. In some newer GIS, several sensors are installed in order to perform a UHF measurement, not only during the commissioning, also in service as a monitoring test. Thanks for your attention, and best regards from Switzerland.
Thank you, Mr. Miesch. Very good and very enriching presentation. So before we enter the Q&A session, I will just give the time to Pak Cawer to give very brief summary from the material that Mr. Miesch deliver. Memberikan waktu singkat saja, 3 menit, Pak Cawer Ginting akan memberikan summary yang sangat singkat untuk mendaratkan materi dari Pak Markus Miesch dalam bahasa Indonesia. Silakan Pak Cawer.
Baik, seperti sudah kita dengar dari Pak Markus Miesch bahwa pengujian setelah pemasangan di lapangan, ada yang paling penting itu adalah dielectric test dari main circuit, dan biasanya ini dilakukan setelah semua pekerjaan baik mechanical maupun electrical selesai dilakukan. Sesuai dengan IAC 62271, ada 2 prosedur. Pertama, prosedur A, kemudian prosedur B. Prosedur A adalah untuk 170 kV ke bawah, dan yang prosedur B adalah yang di atas 245 kV. Perbedaannya adalah yang prosedur A itu hanya power frequency Whiston test saja tanpa partial discharge. Prosedur B itu direkomendasikan selain power frequency voltage test juga dilakukan partial discharge measurement. Tapi beliau mengatakan bahwa selain untuk 170 kV, selain untuk 245 kV ke bawah, diterapkan prosedur B. Prosedur B juga sangat berguna untuk dipergunakan ataupun diaplikasikan pada GIS 170 kV ke bawah. Kenapa? Sebab power frequency resistance test itu hanya melakukan informasi yang kita dapat adalah go dan no go. Kalau ada flashover, maka itu berarti GIS kita tidak lulus. Kalau go, berarti GIS kita lulus. Tetapi ada beberapa gangguan yang tidak bisa dideteksi dalam 1 menit pengujian instant test. Itu sebabnya kenapa banyak pabrikan-pabrikan juga melakukan pengujian HV test berserta partial discharge untuk GIS di bawah 245 kV. Dalam SIGRE, paper SIGRE tahun 98 untuk working 1514 ada aplikasi of partial discharge diagnostic in GIS at on-site commissioning test. Kenapa ini dilakukan? Sebab ada satu konsensus bahwa pengujian HV test yang dilakukan bersamaan dengan partial discharge akan dapat mendeteksi hampir semua potensi-potensi gangguan, kesalahan yang diakibatkan oleh pemasangan. Dan GE, dulu Alstom, telah melakukan HV test plus partial discharge untuk pengujian di lapangan sejak tahun 1991, artinya sudah 30 tahun yang silam, mereka sudah melakukan pengujian HV test plus partial discharge secara resmi. Tetapi saya mengingat pada tahun 1987 di Medan, pemasangan GIS Gelugur dan Mabar, itu tahun 87, kami sudah melakukan HV test plus partial discharge. Tentu waktu itu partial discharge measurement dilakukan dengan alat yang masih analog. Jadi ini kira-kira yang disampaikan oleh Pak Markus bahwa HV test dengan partial discharge merupakan satu site quality assurance yang dapat kita lakukan khususnya di Indonesia yang bisa membuat kita dapat menghasilkan GIS yang terpasang dengan kualitas yang jauh lebih terukur lagi. Demikian kira-kira summary dari presentasi Mr. Miesch, Pak Victor.
Baik, Pak Cawir. Terima kasih atas summary yang sangat baik. Itu ngomong-ngomong tadi dokumen kunonya apakah nanti boleh dibocorkan, dikirimkan kepada peserta?
Boleh, boleh. Nanti ini kebetulan ini ada di SIGRE, ini ada di pada session tahun 98. Kita akan lampirkan untuk bisa dibagikan kepada semua partisipan. Terima kasih.